Welcome to the second video on discussing how to create an APAP system using MatLab and Simulink. If you've not watched the first video, I would highly suggest you first watch that video because I explain how to set up everything that you see currently on the screen. In this video we're going to talk about how we can actually write some logic in this Simulink chart that will actually run everything and complete the APAP system. So if you've not watched part 1, I suggest first watching that one, and then we can start with writing the logic for our chart. The first step is that we go into our chart by double clicking, and then we're going to create our first state. So this is actually our initial state as well, and you can see that it's an initial state by this symbol over here. So this means that the first thing that the system is going to do is go into this state, which we've called the off state. Then in the off state I've just set some variables, for example the mode, which we have set as an output variable in the previous episode. I set that to 0, and then the low and high pulse is something that, or variables that we have not discussed in the previous part. So you can just make these variables by clicking this button over here and then setting these variables as local variables. So for example, you can see that I set it as local data. So what that means is that this data is not expected to come into the system, and it's also not expected to be sent out of the system. So these are the initial conditions for all the variables. If you were wondering how to actually make this arrow that tells the system that this is the initial state or the default state, you can just go to this button over here and add an initial state. The next state that you want to create is the on state, and then you're going to say at the entry of the state. So when the system enters the state, you should change the mode to 1 and make release 0. So I've added release as another local data variable. And then the transition between these two states is going to be determined when the duration of button equals 1 is greater than 3. So what this means is that as soon as someone presses the button, then the constant value is going to change to 1 for button. And you can remember that button is an input variable. So once someone presses the button, then the button's value goes to 1. But we want to wait 3 seconds for the button to be pressed before you actually transition. So if someone just quickly presses the button by mistake, then it won't shift from the off position to the on position. You have to hold in the button for 3 seconds before it goes to the on. Next we're going to add an initial state to the on state, which is going to be the low pulse. So this means that this is the lowest air pressure that the user will experience. So once again I've added this initial state arrow. That means that as soon as the system enters this on state, it will first set mode to 1, then release to 0, and then go to the state which is the low pulse state. Then on the entry of this low pulse state, we're going to set the PWM to low pulse, which will this PWM is obviously an output variable, so that will be sent to the scope. So whatever we've set low pulse to, that's what PWM will be at that stage. That means that, and this next part means that while this is in the low pulse state, if the button is equal to 0, then we make release 1. So this is simply to make sure that the button works correctly, and that it actually takes 3 seconds for someone to press the button, and then after its release it goes back to the 0. Now why this is also important is if you don't add this logic, then if the person holds in the button for 3 seconds, it will go to the on state and then see, okay, the button is still pressed, so it's still at 1, so that means go to the next state, which will be the setting state. So this is just to make sure that even though the user holds in the button for 3 seconds, it still just stays in the on state and doesn't jump to the setting state. But that's going to make sense in a second when we actually add the setting state. Now we're going to add some logic for the LED lights to actually show that the pressure is going down again. So imagine that LED 3 is the red light, LED 2 is the yellow light, and LED 1 is the green light. So after 0.5 seconds, or actually when the system enters this state, the first thing it's going to do is turn off the LED 3, so turn off the red light. Then after 0.5 seconds, if low pulse is actually lower than 15, then we're going to turn off the yellow light, and then after another 0.5 seconds, if low pulse is lower than 10, then we're going to turn off the green light. So this means that if we've set the low pulse to be something that's more than 10, for example, then this green light is never going to go off. So it's always just going to go red light goes off, yellow light goes off, green light stays on, and then when we get to the high pulse state, we're going to put the yellow light on and turn the red light on again. So this is only if it's less than 10 and this is less than 15. Next, I've added the high pulse state, and as you can see, I made two transitions between them, each one after 60 divided by BPM. So remember, we're going to set the BPM using this edit. So let's say, for example, just to make everything easy, I set it to 60 BPM. That means that after 60 divided by 60, which is 1, so 1 second you go to the high pulse, and after 1 second you go to the low pulse, which means that you breathe 60 times in that 1 minute. So let's go to the high pulse state. So at entry, we're going to set the PWM to high pulse. So whatever we've set the high pulse value to be, that's going to be what the PWM's value is going to be. And this PWM is then going to be outputted to the scope. And then after 0. And then we're going to turn on the green light. And then after 0.5 seconds, and if high pulse is more than 10, we're going to put on the yellow light. Then once again after 0.5 seconds, and if high pulse is 15, then we're going to put on the red light. So just the same as with the low pulse, if the high pulse never exceeds 15, for example, and just remember this is an arbitrary value, you can set this to whatever you like. I just chose 15. So if I set the high pulse value to be, let's say, 12, then this red light is never going to turn on. It's always just going to fluctuate between green and yellow. Next, I've created a settings state, which is totally separate from the on state. So this will only activate when the user presses the button again and the release is 1. So as you can see, once we get into the on state, the release is 0, which means that this transition can't happen until the button is not pressed anymore, or if it's 0, then the release would be 1. So that's that safeguard that I set in, that if you hold in the button for 3 seconds, you don't jump between these states constantly. So now once the user has pressed the button, we enter the settings state, and on the entry of the settings state, we're going to set the PWM to 0, because you shouldn't breathe when the settings are being changed. And then we're going to set the LED all 3 of them to 2, which means they're all going to be blue. So let me just show you how I set that up. So if you click here, then you can say that for state 1, for example, it's going to be green, and then for state 2, if I add another state, it's going to be blue. So this just shows that if we set all the LEDs to 2, then everything is going to be blue, and you know that you are in settings mode. And then on exit, we're going to make sure that the settings exit, or S exit, is 0 again. So once again, the default state is the low settings, because we want to make sure that when we're in mode 2, we can set the low pulse. And then on exit, we're going to set the low pulse to whatever the knob is divided by 5, or the value of the knob is. So that's where I got this 15, for example, and this 10. So obviously the knob can go from 0 to 100. So if I divide it by 5, then the maximum that the low pulse, for example, could be is 20. So everything is now a factor of 20. Then if we press the button again, we're going to go to high settings and set the high pulse to whatever the knob is divided by 5, only on exit. So once this state is exited, then and then and only then do we capture the knob value. And then the same thing with the humidity, and we're going to set the settings exit to 1 to make sure that we can actually exit this state. Then I simply added a transition between settings and the on state again. So when the mode is 4, which means that we were setting the humidity, because on entry of the humidity we set the mode to 4, and the button is pressed, then we can go back to the on state, because then we've run out of settings to actually change. So once you've run through the low settings, the high settings, and the humidity settings, and you press the button again, go back to the on state, which will be the breathing state. And now the system is ready to be tested. So if we go to simulation, make sure you set your stop time to infinite, which means that the system will keep on running, the simulation will keep on running as long as you want it to, and then you can just press run. And now the system is running. If I hold in this button, then I should see the mode going to 1, which means that we are in breathing. Then if I want to set the low pressure, I can click again, and the lights indicate that we're in settings mode. Now I want the low pressure to be at around 30, and remember that we were dividing this by 5, so this means that on the scope the low pressure will always be at a 6. And if we press the button again, we can go to the high pressure, and I want to set that at 90. And remember that we're dividing by 5 once again, so this will be at a 18 on the scope. And then the humidity we can just set to around 50, which will mean that it's going to be at a 10. Now we're in the breathing again, and then you will see that these lights go on for the high pressure and then go back down for the low pressure. And then the frequency of how fast these lights turn on and off is set by this edit breaths per minute. So if we add it to 20, then you can see that it's going to start going much faster. So now if I open the scope, then I can just show you that we're at 18 for the high pressure and at 6 for the low pressure, and then the humidity remains constant. As a bonus, you can also add something that periodically changes the humidity if you'd like to, but for simplicity for this project I just kept it at a simple constant. And this is how you create an APAP system using MatLab and Simulink. I hope you enjoyed the video, and please consider subscribing, and I'll see you in the next video.